Hello again, Algebra. Today we are moving on to 4.4, which is solving linear inequalities and graphing. A linear inequality is similar to a linear equation, but the equal sign is replaced with an inequality symbol. The solution of a linear inequality is any ordered pair that makes the inequality true. So if you can recall, if I wanted to find out if a coordinate was on a line, I would take the actual coordinate and substitute it. If it was true, it would be a part of the line. And if it was not true, then it wouldn't be a part of the line. So remember, every coordinate comes with an x and a y. I'm just going to substitute the x in for x and the y in for y. So that 3 times negative 2 is going to give me negative 6 plus 1, and that is indeed equal to negative 5. This tells me that the coordinate point is a part of the line. It is a solution to the line. So let's look at number 2. Again, we know that every coordinate comes with an x and a y. And so if I know that the equation y, my inequality y equals x minus 1, then I can take the x and substitute it in for x and take the y and substitute it in for y. So the 3, which is y, I'll put it in. It's less than x, which is 7, minus 1. So 3 should be less than 6. Well, is that true? Is 3 less than 6? The answer is yes. So then this coordinate would be a solution to the inequality, to the linear inequality. Let's look at number 3. Again, every coordinate comes with an x and a y. And we're just going to substitute to find out, is it true or is it not? So if my y is 5, I'm going to substitute 5 in. It's greater than 3 times x, and x is 4, plus 2. So 5 should be greater than 12 plus 2. 5 should be greater than 14. Well, is 5 greater than 14? No, it is not. So it's not true, which means the coordinate is not a solution to the inequality. So the coordinate is not a solution to the inequality. All right, so that's how we can identify if something is a solution or not. Now let's go on to graphing linear inequalities. If I'm going to graph a linear inequality, I'm going to treat the inequality symbol like I would an equal sign. Try to isolate the y. It's going to be easier if you could get it to slope-intercept form. Remember, that is your bestie. If you recall back in chapter 1, whenever I had an open circle, then if it was, if it was less than or equal to, I had an open circle. And if it was less than or equal to or greater than or equal to, then I had a closed circle. So less than or greater than, it was an open circle, meaning the solution was not a part of the answer. But if it was less than or equal to, greater than or equal to, it was a closed circle. This is going to use something similar. If the graph is greater than or equal to or less than or equal to, we're going to use a solid line. If it is less than or greater than, we're going to use a dotted or an open line, an open boundary line. And then if it's greater than, we're going to shade above, because everything above tends to be greater. Your y values are going up. And if it's below, then we're going to shade below. And then we could use 0, 0 to check. So y is less than or equal to 3x plus 4. Your slope is still 3. Let's go with 3 over 1 because I'm going to need a rise over run. And your y-intercept is 4. So your starting point is 4. And then you're going to go up 3 and write 1. Up 3 and write 1. Now, if I can't go up and right, remember I'm going to go down and left. So 1, 2, 3 and left. 1, 2, 3 and left. 1, 2, 3 and left. Now that I have my line, I need to determine, will it be a solid line or a dotted open line? And when I look, I notice that my sign is greater than or equal to. So it tells me it's going to be a solid line. And then I see that y is less than. Y is less than 3x plus 4. Because it's less than, it's going to be all the lower y values because the y values are going down. So this will be the graph of y is less than or equal to 3x plus 4. Then you probably want to check your coordinate. Let's see which one is true. 0, 0 should work because of its location. So that 0 is less than or equal to 3 times 0 plus 4. 0 should be less than or equal to 4. And that's true. I know I shaded the correct spot. I'm going to use 0, 0 to check because it makes things easier. Let's look at number 2. I would like to graph, but this doesn't look like y equals mx plus b. So first step is to get it there. I have y plus 2x is greater than 8. So I'm going to minus 2x on both sides. So that now y is greater than negative 2x plus 8. I like to get it into slope intercept. It's going to make it easy to graph, and it's going to make it easier for me to shade as well. So then I have, if y is greater than, let me get my coordinate. My y-intercept is going to be 8, and my slope is going to be negative 2 over 1. So I could go down 2 and write 1. So I start at 8. I'm going to go down 2, write 1, down 2, down 2, write 1. Sorry for the graph. Down 2, write 1. And then I want to think, okay, well, will I have a solid line or open line? I'm going to have an open line because this is greater than. There is no or equal to. And so I'm going to graph that line. Because y is greater than, I am going to shade everything above. And all of those coordinates should be a part of the solution, except the coordinates that's a part of the actual line. Those are not a part of the solution. And so we could also check 0, 0, but in this case, 0, 0, because of its location, should not work. So let's see. Or again, you could pick actually any of these coordinates to see if it will work. It's up to you. You actually get some choices here. So 0 is greater than 0 plus 8. 0 is greater than 8. That's not true. I know I shaded the right spot because this area should not be shaded. It should be the other side. All right. Let us go ahead and I'm going to help you out with 3. And then I want you to pause and try 4. So for 3, it's in standard form. I can graph from standard form, right? Remember, you would cover up the y. So I know that the x-intercept is 3. And the y-intercept would be negative 4. And then we would have to be guessing which side. I know that it should be an open line because of the greater than. It's not or equal to, so I know it's going to be an open line. And then I would have to pick a point to find out which side do I need to shade. Do I shade above or do I shade below? If I want to graph from slope intercept form, I'm going to change this to slope-intercept so that 4x minus 3y is greater than 12. So I would minus 4x on both sides. Negative 3y then is greater than negative 4x plus 12. And then I would divide both sides by negative 3 so that y is less than inequality. If I multiply or divide by a negative, I also need to flip the sign. So it will be less than 4/3 x minus 4. And so you would see that it's a similar thing. I would start at negative 4. I would rise 4, 1, 2, 3, 4, and to the right 3. Here I am at the same coordinate. Up 1, 2, 3, 4, 1, 2, 3. There I am on my coordinate. So if you go from standard form or slope-intercept form, you're going to end up with the same thing. But this way, you'll find out that your y should be less than. So it would be shaded on this side. If you'd like to check, you could pick any of these coordinates. Or again, you could try 0, 0, but 0, 0 in this case should not work. I'm going to try one that would work. Maybe I'll go with 4, negative 1. That looks good. So I'm going to use 4, negative 1 to check. I'm just picking any point from this right side. And so if I do that, let's see. Y is less than 4/3 x minus 4. So negative 1 should be less than 4/3 times 4 minus 4. So that negative 1 is less than 16/3 minus 4. Negative 1 is less than, is that 5.3? 15 and 1/3. Minus 4. So negative 1 is less than 1.3. And that is true. So I know that, yes, that side of the equation would work. If I tried 0, 0, then 0 would be less than negative 4. And that would not be true. So then I would not shade that side. That side is not shaded, and the correct side is shaded. This part is true. Go ahead and pause, and then I want you to try number 4 all by yourself. All right, so we would have a solid line. Your y-intercept is at 1, down to right 3. You would have shaded the top because y is greater than. And then I chose the coordinate 3, 1 to use as a check. It should be true because it's a part of the solution area, and indeed it was. All right, so now we're going to write an inequality from a graph. First, we're going to find the y-intercept, find the slope. Let's get that equation in slope-intercept form. And then we're going to determine if it's going to be less than or greater than or less than, or greater than or equal to, or less than or equal to, based on the shading. All right, so number 1, I know my y-intercept is 1. To get from there to the next point, which I see, I would go up 1, right 2. So that I know that my slope is 1/2, and I know that the y-intercept is 1. So I'm going to write my equation. I also see that the line is open. That tells me it's going to be a greater than or a less than. But I do see that it's shaded below, which tells me it's going to be a less than. Why is less than? Because it's below. So these are all information I'm going to take from the graph. And now I'm going to write the equation. It should look like y equals mx plus b, but again, not an equal sign. So that I know it's y is less than 1/2 x, and my y-intercept is 1. There's my equation. For number 2, I see that my line is a vertical line. It's going through the x-axis. And because it goes through the x-axis, it's an undefined slope. I know that this is x equals a number. What number is it? 2. So this is x equals 2. But oh, lo and behold, it is shaded on the right side. This is a solid line. So I know that if it's on the right side, my x would have to be greater. And because the line is solid, it's going to be greater than or equal to. So now my answer is x is greater than or equal to 2. Go ahead and pause and try number 3. All right, now that you are back, I noticed that my y-intercept is 4. So my b is 4. I need the slope, so I'm going to count. To get from here to here, I'd have to go down 2, right 3. Down 2, right 3. So my slope is negative 2/3. I see that this is a solid line, and this is above, which means it's greater than. It's going to be greater than or equal to because the line is solid. So now I know it's greater than or equal to y equals mx plus b loosely. I know it's y is greater than or equal to negative 2/3 x plus 4. And I got all those information from the graph. Thank you for joining me. And remember, in order to learn your mathematics, you must do your mathematics.